Okay, so in this video we're going to try and reduce a lot of information about properties of materials, and we're going to try and put it into a table that should be, hopefully, easier to remember. So let's look at why we want to use a table to remember all this information. Well, you can see all these questions here you could be asked at GCSE, and they all look fairly unrelated, but really there are patterns in here, and we're going to try and use the table to identify these patterns, and hopefully that will help us memorize the information. So this is the table we're going to use, and we'll fill it out as we go through the video. You can see some parts of it are only required for hire. Some bits don't apply, and we'll talk about that when we get there. And finally, what I'm going to do with the pen is just describe the properties, but I'm going to use the word because verbally. When I say because, listen closely to what I'm saying, because I'm explaining the properties, and you might like to annotate those explanations on your table. I imagine you'll need to write quite small though to get all the information on. Okay, so first of all, let's just look at what these headings at the top mean for the table. So let's look at the description of the bond first. You need to know that these three are all strong bonds, and you can see the explanations of what the bonds are. The only bond that is a weak bond is an intermolecular bond, and that's the properties of simple covalent substances you really need to explain for the higher one, but you need to know what they are for the foundation paper. So let's look at, first of all, the end heading on our column here. Does the substance conduct electricity? And reasons for being able to conduct electricity are being able to carry the charge, so either the electrons can carry it or the ions can carry the charge. If a substance cannot conduct electricity, the electrons cannot move to carry, or the ions cannot move. And you have to be really careful that you use the correct word, ions or electrons. If you use the wrong words in your answer in the exam, you automatically get 0, which is a bit harsh really, so you have to be very careful there. So next of all, let's look at these. These are all linked here, so let's see why they're linked. If you're looking at the description of the bond, if it's one of the stronger bonds, these three, the substance will have higher boiling and melting points, and that is because it will require more energy to break the bonds, to turn the substance from a solid into a liquid, into a gas. It will tend to be a solid at room temperature, because at room temperature there's not enough energy available to break the bonds. So substances with weaker bonding, simple covalent substances, tend to be liquids or gases at room temperature, and strong substances with stronger bonds tend to be harder, weaker bonds softer. Okay, so if we look at the first three rows of the table, we've got ionic solid, which is shown here, ionic molten, which is just melted, so it's been heated up to form a liquid, and then we've got an ionic solution here, and you can see there's water molecules in here, and they've got the ions around attached to them. So the description of the bond here, if we've got ionic solid, strong bonds, it's attraction between oppositely charged ions, so the boiling and melting points are going to be high because it's a strong bond. It's going to tend to be a solid at room temperature because it's a strong bond. It's going to tend to be fairly hard because it's a strong bond. And is it going to conduct electricity? Well, this is the tricky one here. You need to think, can the ions move to carry the charge? Well, it's a solid. These particles can't move in a solid, so no, it cannot conduct electricity because the ions are not free to carry the charge. They cannot move. If we think about these next two, well, really, this is kind of irrelevant because it's an ionic substance, even melted, so it's hotter, and that's changing the properties, or it's an ionic substance that's dissolved in a liquid, so a lot of the properties are going to depend on the liquid, which is usually water for us. So let's just look at the last column. can a molten ionic substance conduct electricity? Well, ask yourself the question, can the ions move? Well, yes they can, it's a liquid. So can it conduct electricity? Yes it can, because the ions can move to carry the charge. This last example, an ionic solution, can the ions move? Well yes, again it's a liquid, so the ions are free to move to carry the charge, so it can conduct electricity. So covalent next. These were the next 3 rows down on the table. Let's look at giant covalent first. Examples, this could be diamond or silicon oxide, which is sand. So description of the bond, it's a strong bond formed by sharing of a pair of electrons, and the electrons, think of them as being aligned along these lines. That's where the electrons are, so they're not really free to move. That's important when we're thinking about electricity. So it's a strong bond, boiling and melting points are going to be high because it's a strong bond. It's going to be a solid at room temperature because it's a strong bond, and it's going to tend to be hard. Does it conduct electricity? No, because the electrons are not able to move. They're held in this covalent bond. Notice I said electrons there, that's really important. There are no ions in a covalent substance. Right, so let's look at simple covalent next. So the bottom row, here I've shown a methane molecule. You can see there's a covalent bond here of sharing a pair of electrons between carbon and hydrogen. And these are the intermolecular bonds. You can see I've drawn them as dots because they're so weak. So the description of the bond is a weak bond, the only weak bond we're looking at. And it's formed by attraction between temporary charges on the molecules. You don't need to go into detail about that. So it's weak, so the boiling and melting points are going to be low. It's going to tend to be a liquid or a gas at room temperature. It's going to tend to be soft. And does it conduct electricity? Well, can you see any ions? No, there's no ions there. And the electrons free to move to carry the charge? No, they're held in the bond, so they do not conduct electricity because there are no free ions or electrons there to carry the charge. Graphite, well there's only one graphite, but you might get a big 5 or 6 mark question on this, and we'll go into quite a lot of detail on this. The description of the bonding, we'll just do it really briefly here. You've got these sheets here which are kind of like layers with a very strong covalent bonds. You can see there's only 3 bonds for each carbon that's in there, and because carbon's in group 4 it should have 4 bonds because it's got 4 electrons in its outer ring. That third electron that's not used in one of these 3 bonds is here, it's delocalized, it's free to move between the layers. And because you've got these delocalized electrons that are free to move, yes, it can conduct electricity. So you've got these stronger layers, and then you've got these very weak bonds between the layers. So graphite's a bit strange. Boiling and melting points are still, high, medium, because you've got these stronger bonds there. It's a solid. Graphite is a solid. But is it hard or soft? Strange one. It's slippery. These layers can slide over each other because of the weak bonds between the layers. So that's why graphite's often used as a lubricant. So let's call that. Let's leave that blank and say it's kind of slippery. It's softish. The layers will slide over each other. Okay, that's right. Right. So here's the table. We've looked at these top 3. We've looked at covalent. Let's just have a look at the last step on the metals. And for metals, we get this question about hard or soft again. And just have a quick look at this description. People often think hardness and strength is the same thing. It's not. Something can be strength without being hard and vice versa. So let's have a look. Metallic, pure metallic, yeah, it's pure. It's an element. It's made of one type of atom. And compare that to alloys. You can see here I've got 2 different types of atom in there, and that helps describe some of the properties. But before we do that, let's look at the description of the bonds. Well, here you've got your positive nucleus in each atom, and around it you've got orbitals, or the shells of the electrons, and they overlap. That's what this grey area is here. You imagine you've got the orbitals from that atom, and they're overlapping that around it. You see it overlapping. So when we look at the description of the bond, it's still a strong bond because this positive nucleus is actually attracted to those negative electrons in that atom, and those. So the nuclei is attracted to the electrons from the atoms around it as well as its own. So that's what a metallic bond is. Right, it's a strong bond, high boiling and melting points. It's going to tend to be a solid at room temperature. Pure metals, because the layers can slide over each other, because all the atoms are the same size, we tend to say they're kind of medium-ish, not very, very soft, but they will move. You can knock bits out of there, you could knock a layer off that quite easily. So let's say fairly soft for pure metals, and they don't have much strength either. Like pure iron, you apply a force to it, you can bend it, so it hasn't got a lot of strength. Does it conduct electricity? Well, yes, of course metals conduct electricity. Oops. Yes, because the electrons are free to move through these orbitals from atom to atom because they overlap. So yes, the electrons are free to carry the charge. Alloys. Same thing, strong bond, high boiling and melting points, solid at room temperature because of the strong bonds. Hard or soft, well this time you imagine trying to slide one of those layers over the other one. Can't really do it because of the difference in sizes of the atoms. So you tend to say they've got more strength, and you could say they're harder. But there's a lot of variation in alloys, and that's worth reading up on its own. That's quite a big subject to look at. Okay, so I'm going to leave you with a blank table. You could print that out if you haven't already got a copy, or test yourself and see can you put a high, medium or low, and the because in each box to explain why it's got certain properties. That's quite difficult with a lot of information. And there's some questions there as well. That's another way of looking at it, I suppose. Okay, thank you very much.